at the top here of page 189, it says use your prediction from item 10 to write the equation of two lines that are perpendicular. So I chose two different lines. I called one of them y1 and the other one y2, kind of like L1 and L2. And notice the slopes, 2/3 and then -3/2. Now, opposite reciprocals, they have different intercepts. So I'm going to go over here now to my graph, and I'm going to graph a y-intercept of 4 and then a slope of 2/3, and this is also 2/3 here. Now, if I draw this using my Venture card again, okay, and draw a nice straight line here, then I draw my second line. It has an intercept of 1, and it has a slope of -3/2. So -3/2, down 3/2, like this. Now notice that when I draw this second line, and if I put my Venture card on here, you can see that I get a nice right angle here, nice 90-degree angle. And again, I have two lines whose slopes are opposite reciprocals. Now, if you look in question number 12, in the coordinate plane, what is true about a line that is perpendicular to a horizontal line? Now, a horizontal line would have a slope of 0. The slope is 0. And if it would be perpendicular to that, all right, perpendicular, here's a symbol that means right angle or perpendicular to. If this is a slope that is 0, then perpendicular to a horizontal line would be a vertical line. Okay, so a line that is perpendicular to a horizontal would be vertical. Now, in number 13, we're starting with 3 different points. We're starting with 0, -1, okay, 0, -1, 3, 1, 3, 1, and if we graph those 2 points, we can see that this has a slope of 2/3, all right, similar to the line that I had done up there. Okay, now we know that the slope between 0, -1, and 3, 1, this has a slope of 2/3. So -1 to 3, 1, okay, that has a slope of 2/3. So here our slope is 2/3. Now, line 1 contains these 2 points, okay? But it is perpendicular to a line that contains -1, 2. So here's our line. I'll just draw a little part of this line. And this is perpendicular to a point that contains -1, 2. -1, 2. So if this has a slope of 2/3, then the slope of the other one, slope of the other one must be the opposite reciprocal. So its slope would have to be -3/2. Now you can see that these go through different points than the ones I had up here, but they have the same slopes, 2/3, 2/3, -3/2, and -3/2. And as long as they are opposite reciprocals, then we know that they will be perpendicular. Now, we are asked to write the equation of each line. Now, the equation of the first line, we know that the slope is 2/3, and 0, -1 is a very important point because it is the y-intercept. So we can write our equation directly as 2/3 x minus 1. Now, L2, we know that the slope is -3/2, and it goes through negative 1, 2. So if it goes through negative 1, 2 and has a slope of negative 3/2, I can write this in point slope form. Y minus 2 equals negative 3/2 x plus 1. Now, people may not like this form, and if you want to rewrite it, we could write it as negative 3/2 x minus 3/2, and then we would add 2 to the other side, and that would give us negative 3/2 x. This is negative 1/2, negative 1.5 plus 2, so that would give us plus 1/2. Plus 1/2. Now, in number 14, it says determine whether slopes are parallel, perpendicular, or neither. Now, in part A, I'm just going to put a 1 here so that we can see it as a fraction. And these are opposite reciprocals. So in part A, these are perpendicular. So A would be perpendicular. Okay. Now the symbol for perpendicular is a symbol that looks like this. In part B, we have negative 3 and 3. These are opposites, but they're not opposite reciprocals, and they're not the same. So this is neither. Now in part C, we've got 10 over 12. And 10 over 12 could be written as 5 over 6. And the opposite reciprocal of that would be negative 6/5, which is negative 1 1/5. So in letter C, these are perpendicular because they are opposite reciprocals of one another. Letter D, these slopes are the same. So part D, we know that these are parallel.